So let's take a minute to read this question. The rate at which water leaks from a tank in gallons per hour is modeled by R, a differentiable function of the number of hours after the leak is discovered. So here we've got our function for R, and this units are going to be in gallons per hour. What is the value and physical meaning of each of the following? And we're going to use a calculator for these. So the first one, A, well, the answer, and again, this is just a reminder, hey, let's use Math 9 on our calculator, and it will come up with negative 32.540, and these units would be gallons. Because if we think about finding the area under some curve that are gallons per minute, and minutes is our x-axis, if we were to find one of these rectangles, we would have gallons per minute for the y times the x in minutes. This would be minutes. This would be gallons per minute. Those minutes will cancel, giving just gallons. And you can use that kind of approach to find any set of units. So now this most important physical meaning, what does this mean? Well, this means the change in volume or gallons in the tank from 0 to 6 hours. And notice we had a negative value, so that's not only a change, but we could also say that is a loss in gallons because of the negative value. As we think about part B, we are not given an upper limit. This is a variable now. And we're also given a value that's to start with. So really, we're going to skip right to the physical meaning. The physical meaning is that there were 30 gallons in the tank at t equals 0. And this equation will give us the volume at time x for any time x. And that's what this is going to give you. We could actually find the integral if we wanted. If you were to go ahead and take this antiderivative by hand, and you could, then you would get this expression, which would give you the volume in the tank at any time x. So x is our time. For part C, you'll see that I changed the starting value to 40, and I think you'll see why when we do the problem. This is, again, a problem we can go right to Math 9 on our calculator. And the answer is 7.4599 or 7.460 gallons. The reason I changed from 30 to 40 is when I had a 30, the answer was negative 2.540 gallons. And there's no way, once we hit the 0 point, if there was only 30 gallons in to begin with, you couldn't end up with a negative amount of gallons in the tank. The lowest this could go was 0, so that was kind of a bad problem. So we changed that to 40 so it works out better. But the most important thing is the meaning here. What does this represent? This represents the volume in the tank at t equals 6 hours. How would you actually calculate it? Because you've been given R as this rate, you're just going to substitute 3 in for the time. and the value is negative 5.016. What are the units? Well, because this is R, and you've been given R as gallons per hour, then this is just the rate that water, in this case, is leaking out of the tank. Because we have a negative rate, we are not adding gallons over time, we are subtracting. So this would be the rate that water leaks from the tank. So to calculate part E, again, I would use Math 8 on my calculator. And you're going to plug in something that looks just like what's been written here, where T will be 3. You won't plug it in here. The T will go in the formula, but T equals 3 will be the instant that we're looking at. And our answer is 1.154, and our units would now be gallons per hour, which we had originally for the original rate, per hour, because we're taking the derivative of that rate. What are the units? I'm sorry, what's the meaning? The meaning is at the instant T equals 3, the rate that water leaks from the tank is increasing at a rate of 1.154 gallons per hour per hour. A couple things to keep in mind. We've got to talk about the rate and then the change or increase of that rate. So we really have two rates, the rate of change of the rate, and here's our two rates signifying two sets of division. We should say increasing because this was a positive value, and you may be thinking, wait a minute, how on earth could this be increasing if water is leaking? But if we take a look at the graph of this original rate, we start down here at negative 10, and we've got a exponential function like this. Right here at t equals 3, this slope is positive. That just means that it's getting less negative, the rate, as time goes on. So it doesn't mean it's not leaking. It's still leaking. It's just leaking at a slower rate, or the negative rate is becoming more and more positive. For the average rate of change of R, we're really just looking for the slope, or the rate at 3 minus the rate at 0, all divided by 3 minus 0. When we do this calculation, we get 1.661. And taking a look at our units, we had gallons per hour in the numerator and hours in the denominator, so we're going to have gallons per hour, or you could write it as gallons per hour squared. And another look at the graph. This was what our graph looked like. The last problem, we had a rate right here, I think it was 1.15 roughly. The rate that we're looking for is the average, or the secant slope of the blue line. Notice the blue line is steeper than the red line, and this 1.611 is greater than our instantaneous slope of 1.115 or whatever we had from the previous problem. Now take a look at all of these different kinds of rates and accumulations where we're using integrals and derivatives all together, and see if you can decide when you're taking a derivative, what it means, when you're taking an integral, what it means, when there's a starting value, when there's not, when you should use it. Practice is where you'll really become ready for all of the different things that you can see on something like the AP test.